Hello, and welcome to another episode of Fun Times and Statistics. As always, I will be your host. My name is Rochelle Barr, and I like math. Hey, I am doing some chi-square tests today. This is the more complicated of the chi-square tests, and we are going to be working with looking at gender versus activity level. You'll notice that my data on the side is neither of those because our first type of test we're going to do is using a table for the chi-square test of independence, and then we're going to move on to using the data in example number 2. So we need that data, just not yet. Cool. So you may recognize that I'm using the pulse data to do this. We did use this data set earlier in the semester, but I took the liberty of turning it into a table for you so you could see what would happen if you had just a table of values to work with in Minitab. So what we're going to be looking at here is we want to see if gender and activity level are related or if they have an impact on each other. So that's exactly what my ho and my ha are going to say. So my null hypothesis for the test of independence is always that the two variables are independent. So I'm going to say that gender is independent of activity level. Woohoo! Or if you like, that certain genders are not more active than others is what we're going to assume. And then our data will either support or not support that. And so my alternative is that gender is not independent of activity level. Actually, that's phrased really poorly. I would think that activity level is independent of gender, so gender has no impact on there. I like the way that's phrased better. It really doesn't matter, but I think that makes more sense when you think about it. Boy, activity level is hard to spell. Is not independent of gender. So one thing I want to point out to you as I write these hypotheses is the first one, the one of them being independent, is really saying that these two have no relationship or no impact on each other. And then the second one is really saying they have a relationship. So knowing someone's gender tells you something about their activity level. They are related. So as weird as it seems, I don't know if you remember when we first started talking about null and alternative hypotheses, we want to reject because it says something happens. And this really reflects that idea that if I reject my hoe, then I'm going to be looking at, oh, they're not independent. They have some sort of relationship. They have an impact on each other. There's something going on. You know what I mean? Cool. So we're going to copy this table into Minitab. So I'm going to have to be very careful with doing this. I actually am not going to grab the activity part. And if there were any total sections on this table, you wouldn't copy those either. And you should be able to paste this directly into Minitab. Now, some things to notice and be careful about is make sure that your categorical variable you've got making your rows, so gender in my case, shows up as a T for text. And then the others don't have the little t because they are supposed to be counts. Now, if yours pastes incorrectly or doesn't seem to paste well, you can just type the table like this into Minitab, where you've got your rows and your columns aligned correctly, with your text being your categories for the variable that is making your rows. And you're not going to grab the name of the one that's making your columns, because that will definitely screw Minitab up. So now that I've got this in place, I'm going to go ahead and perform my test. Because that's the next step, right? Oh yeah, get my chi-square test statistic and get my expected values. Minitab's going to do this all at once. You could do the expected values yourself by doing the totals for the rows and columns, then multiplying them together and dividing by the overall total. I want Minitab to do this for me so you can prove to yourself that all those fractions I did in the notes were really a waste of your time. Let's go to stat tables. I hate myself. Whew. We're going to be going to the chi-square test for association. Now, you can also use the cross-tabulation chi-square to do this, but I am not going to because that one tends to work better for our second example, or one where you have raw data that are just in columns. So I'm going to be using the test for association. You can do both. Now, you'll notice there's a drop-down arrow that says, do you have raw data? And I want to use one of my variables to make my rows and the other one to make my columns. That's the selection you're going to want to make for like the racial steering example, the second example, where I've got one column that makes my rows and one column that makes my columns. I don't have that. I have a summarized table. So I want to change that radial drop-down to summarized two-way table. Then it's going to ask you for the columns that contain the table. So I need all three of them in there. And then I want to tell it what makes my rows, the column with the row variable labels, and that's my gender column. That just helps it keep track of these two variables. Otherwise, it's going to label them number 1 and number 2, and that's a little confusing. All right. Next up, we're going to hit the statistics button. You want to check to make sure that this is actually going to do the chi-square test statistic. It's also going to do a bunch of marginal stuff. I mean, I don't really want the marginals, I just want the counts and the expected values. The other thing I'm going to ask for is each cell's contribution to chi-square. So that's going to tell me my contribution to chi. Remember, a big contribution to chi means there's a significant difference there. So these are what I suggest you select for coming to these. And the cells are going to be complicated to read, so prepare yourself. Let's hit OK. And then hit OK again, because I forgot there was a second one. Woohoo! So as you look at these cells in this table, it is complicated. There's 3 things in the male allot column, or sorry, male allot square. The first one is the count according to the cell contents. The second one is the expected count. And then the last one's contributions to chi. So that was doing your observed minus expected squared and then divide by your expected. So the value I need to answer step 3 is actually that 8.077 because that's the expected one. And I'm going to do the same thing going through and finishing the male one, 23.462, because those are my expected. So looking down at cell count, the thing that's second in there is your expecteds. My slight is 3.462. I'll tell you why I said uh-oh in a minute. 12.923. I'm hoping you're doing this with me and following along. 0.17, oops, that's the wrong one. 37.538, and then 5.538. Cool. So I'm going to make this session window a little bit bigger. Yep, and it does have the yell at me thing. So notice down here it gives you a little caution at the very bottom of your test. Hey, one of your cells has an expected count less than 5. It's because the slight male category is too small. Now looking at this, I've highlighted it because you need to be cautious here that you actually have failed to meet the requirements of the chi-square test because you have one expected count that's too small. There is one cell with a too small expected count to use the chi-square test on this data. So what you would really do, or usually do when this happens to you, is just be like, okay, well, I need more data, so you'd go out and you get another sample, because this is clearly not enough for you to be able to use it. I'm going to finish this question just so we can get this done. Okay, I wanted to show you one that broke, so there it is. And remember, when it comes to that at least 5 rule, you only have to check the expecteds, not the original. So it's only this table that you check, not the original sample data. So you do have to calculate the expecteds before you know whether or not the test is going to come out okay. Step 4, I need the chi-square test statistic. We can read that right off the chi-square test. It's the Pearson one, so it's going to be 2.487. We've been doing the Pearson chi. The likelihood ratio isn't that different. How many degrees of freedom? Well, there were 2 because this was a, well, let's actually calculate it so you can prove to yourself it is 2. I know Minitab gives it to you, but there's a reason. So when you look at the activity level, there's 3 variables there, so you get 3 minus 1 from the contributions from the columns. And then from the rows, there are 2, male and female, so 2 minus 1, which would give you 2 times 1, which is just a 2. Or you can read it off of the test statistic values, or the chi-square test values in Minitab. All right, last but not least, no wait, I'm not done. I gotta find my p-value and then make my conclusion. So my p-value is 0.288. That's pretty big. It's much bigger than 5%. So I'm clearly going to be choosing to fail to reject. The null hypothesis. Time to write ourselves a conclusion. We're going to be specific and use complete sentences and make sure we're relating it to the context. Why I keep writing this in detail is that I don't want you to write fail to reject, blah. And that's it. That is not a conclusion. A conclusion actually answers the question that's being posed. In this case, we are asked, does gender have an impact on somebody's activity level? And the answer is no. The evidence suggests that gender has no impact on someone's activity level. Another way you could state this is that there is no difference in the activity levels of the genders, of different genders. There we go. I fixed it. Grammar, very important. Then you don't sound like an idiot. Cool. That's it for this. Let's all get all kinds of awkward because it's time to talk about some racism. So I got this from a book that we used to use in one of my other classes a long time ago. It's based off a real court case where they were trying to investigate whether or not apartment agents that were selling to two different complexes were steering certain races towards one complex, and when I mean steering, encouraging them to purchase their condo and or apartment from one apartment complex versus another based on their race. This is what's known as racial steering, and it is a form of racism, and it is illegal. So let's look at this data and let's see whether or not racial steering was evident from this apartment complex. So what they did is they took sales, I think it's all sales that they did, and looked at the races of those people in the two different parts. They called them Section A and Section B to see if there was indeed racial steering present. So, what are we going to call for our hoe? We're going to see, does race end up being independent? Let's actually do it the other way. Let's do housing section is independent of race. So this is saying that there is no relationship between race and what housing section they were encouraged to purchase from or they were shown. So no relationship. And then the alternative is going to be, ooh, it looks like race did have an impact or had some sort of relationship with housing section they were shown. Is not independent of race. And this is the bad one. This is the racism one. This is, I just wanted to write racism. Yay. Relationship. No, not yay to racism. Oh, this is so awkward. I like giving you guys real data because it's important that you see something real, but at the same time, awkward. So I have my data in columns by race and then housing section count, like what's housing they were given. So I'm going to need Minitab to do both for me. It's going to make both the observed and the expecteds and all the stuff I'm going to need to perform this test. So this is a little bit different from what we've done before. So for this one, I'm going to go to Stat, Tables, and I'm going to use the cross tabulation chi-square. I just like this one a little bit better. Cool. So for this one, I'm going to put in my rows, what did I pick for rows? Housing section. And then for columns, I've got race making my columns. And then I want to hit chi-squared. Make sure it's doing the chi-squared test. This is something to watch out for. See how it doesn't have it checked? So I need to do that. I want the expecteds and I want the contributions. So make sure you check those two. You need the expected cell counts to make step 3. And I want each contribution to chi so I can see whether or not there's something going on there. I'm going to hit OK. Let's check our other options just to be safe. I don't need that. Other stats. Okay, if you want the Fisher's exact or the Cramers measure for V, you can check those as well. Those were talked about a little bit in your notes, so if you want those, you can actually click on that for this one. So I'm going to do the Fisher's exact test. Let's hit OK, and then hit OK again. Was the Fisher's the one we skipped? Nope, we did Tukey last time, so it's fine. Oh no, Tukey was what we did with ANOVA. I'm losing track of my own thoughts. All right, so here I've got to be careful. Ooh, that's a tiny p-value. Okay, well that's interesting. And this one has a really small p-value too. Ooh, looks like we're headed towards super rejection land. Oops. Sorry about that. Let me turn off my calendar real quick. I apologize for that. The other thing I had to do is I had to go look to make sure which ones you all needed for, come on, brain. Yeah. Don't worry about it. We're going to ignore the Fisher exact test for now because I actually need the other one. I clicked the wrong button. It's at the end. You'll see it at the end of the document. I meant to do Cramers V and I clicked the wrong button because I was thinking about the ANOVA, which was last week. This is what happens when I try to do all your notes at once. Yeah. Anyway, so for the table we have here, I've got my observes on top, then my expecteds, and my contributions. So I just need to separate that into my observes. So 87, that's not looking so good. 34 and 83. Let me make these red and big, and hopefully you see those on yours. And then for the expecteds, we got 18.82. 76.18. Okay, not too different. 23.18. 93.82. You can get the more decimal places if you want to, but it kind of doesn't matter. There we go. So now we've got our comparisons of expected values to the observed, and then we've got our contributions to chi. These aren't horribly huge, but when you compare them to the test statistic, you're like, oh, well, that is kind of big when you look at the numbers of degrees of freedom, because there's not many. So our chi-square test statistic is only 14.058, which is quite big when your degrees of freedom is only 2. So that means I have some significant evidence probably. Let's take a look at our p-value. It's very small. Let's see if I can actually get a couple more decimal places of this. So remember, you can hover over a numerical value on Minitab and then right click to get decimal places. Let's make this do like 7. Oh, okay. It's still tiny, but you know, there we go. 0.00018, just to be a little more specific. Why am I putting that here? That's the p-value. Schwoops. How many degrees of freedom? 1. I called that 2 earlier. Gosh, I need to not record all these videos at once. I'm not very sharp. Anyway, so p-value, super small. Oh, so small. Time to reject that hoe. Uh-oh. See why there was a lawsuit? Racism. Boo. Okay, so here we go. What do I want to say for this? There is evidence of racial steering. Steering the housing section was not independent of race. So there you go. Which is exactly why there was a lawsuit and why this data exists, which is kind of interesting. Not that racism is interesting, that you're able to figure out this much from just the data. So what I'm going to look at next is what's called Cramers V squared measure of association. This is trying to measure the strength of how these are associated with each other. This is a little bit like the value of R squared, if you remember that from looking at Stats 1 as to how strongly related two quantitative variables are. It's not the best measure of association, but it works. So what we're looking for is it ranges from 0 to 1. The larger the value is, the stronger the relationship. We're going to interpret this like a percentage because of that. And a value of 1 means it's super, super strong. So we're going to do the Cramers V to this. So how we're going to do that is we're just going to hit the Edit Last Dialog box and go back to that Other Stats button and collect the correct one. The other measures of association, the Cramers V squared statistic. I'm showing you this one because it is the one that they prefer to use when it comes to marketing statistics. So if you're somebody who's in the, oh God, what is the name of that class? The class where they do the big market research report. Market research, oh my gosh. You will probably need this, and it's preferred that you use Cramers V. Just so you know. So that's why we're looking at that one. So it's going to show up all the way up at the bottom. So my Cramers measure of association is pretty large. Oh no, wait, it's pretty small. So what you would say from this is, although they're related and it's a strong enough relationship to be detected, the Cramers V is only about 6%. So the relationship is not very strong, with only a 6.7, we'll call it 6.63% Cramers V. So it's not very strong, but it is a relationship. We're a relation shop if you're me today. O and I are right next to each other. Stop blaming me. Okay, I would like to see this a little bit stronger, but evidently there's enough evidence for that 6% So there's 6% to have an impact, which is bad. Um, so one thing I want you to keep in mind when you're looking at Cramers V, just because it's not very large doesn't mean it isn't significant. So be careful with that. It's a common misconception about using Cramers V's test for association. So relationship is not very strong, with only about 6% having an impact, but there is still an impact, enough of an impact for it to be significant. But it is still a significant impact. And this is something you should do, though. Once you see, is there an impact, you should try to measure how big is that impact. So there you go. Okay, I hope you enjoyed this episode, and I will see you next